Next, we're going to learn how to add two vectors graphically, and then we're going to learn how to add two vectors. If we know how to add two vectors graphically, then we can add the third one, fourth one. And same thing, if we know how to add two vectors mathematically, and we can do the third one, the fourth one, so far so forth. So these A, B are in bold letter, but let's add an arrow indicating that's vector. So vector A plus vector B, this R actually means resultant vector. This is a very typical name of tip to tail method. What does that mean? This is the tail of A, tail. This is the tip of A. And we line up the B's tail with, this is B's tail, with A's tip, and this is B's tip. So tail, tip, after that, the resultant is from the first one's tail to the last one's tip. That gives us resultant A plus B. What does that mean? For example, if somebody this is a displacement A. After that, the second displacement calls B. So this person ends up here. If we ask for now, where is this person? We take the initial point as reference, initial point to the final, that is where is this person. So this is the resultant vector of A plus B. Now I want to point out, we might have two vectors. One is given, say, A is this way, and let's say B is right here. How do we add them? Well, remember, a vector has magnitude and direction. As long as we keep the magnitude, which is the length, and we keep the direction, then they're the same vector. So I can actually move this B parallelly. Parallel means keep the direction, and then we have to make sure the same length. This is, let's say if it's 1 centimeter, here's 1 centimeter. What I am doing right now is actually I line up A's tail with B's tail. This is another method of adding two vectors, and this is called tail to tail method. When we add two vectors tail to tail, the resultant vector, can you imagine if I do tail to tail, then this B, where this B was supposed to be? I can move this B, right? Because I said if you move parallelly, and it will be the same if we keep the same length. So if I move this B parallelly, this is my B. This B and that B, if it's parallel, same length, then I move B's tail to A's tail. So A plus B, now you realize the resultant, if you move two vectors tail to tail, the resultant actually is the diagonal of this parallelogram. We use A and B as the two sides of parallelogram, and the diagonal is the resultant of A plus B. So either way, tail, tip, and from first one tail to last one tip give you the resultant. Or if you bring two vectors tail together, A and B, they use A and B to construct a parallelogram. The diagonal is the resultant, and then you get the same result. Now, if we have multiple vectors, if we want to add them, you can see this is A, this is B, so this is the tail tip method. And if you add A and B, that's this. So if you want to add C, C's tail goes to this resultant. So this one is A plus B. Let's name resultant R1. Now if we want to add R1 to the C, then C's tail is here, C's tip is here. So this one is that R1 plus C, let's name R2. Then we're going to add another one, which is D. The tails are here already. So the R2 plus D give us the final one. What is the final one? That is A plus B plus C plus D. That is the final resultant. So it's very interesting. That's very pretty picture that A, B, C, D, you just put each vector. If vectors are from somewhere else, you have to move them parallelly. Just make sure that first one's tail, first one's tip, the second one's tail, tip, tail, tip, tail, tip, and until you finish all lining up all the vectors, and then from first one's tail point to the last one's tip, that is your resultant vector. That is how graphically we add vectors. Now I would like to introduce the concept a negative of a vector. A negative vector is that a plus negative a equal to 0. So this is negative of a vector. That means you add a positive vector, negative vector, and then cancel each other. That's negative of a vector. That's the concept. Graphically, what does that mean? If you have an a, it's a red one. You want to add a negative a. Negative a actually have the same magnitude, just simply opposite direction. So as if you start from here, you go to here, and then you come back to here. So the resultant is 0. Therefore, once we have a vector, if we want to get a negative a vector, simply draw a vector same length but opposite direction, which is 180 degrees direction difference. Then we get the negative of a vector. This is very interesting because we just learned how to add A and B. Say for example this is A and that is B. So if we use tail tip method, that is A's tail and A's tip. Then line of B's tail, B's tip. So what is the resultant? The resultant is from first one's tail to last one's tip. So this one is A plus B. If we want to tail, we learn there's another method, right? How do we do that? Well, if this is A, which is point to the right, we'll keep the same length. B, if it's that way, that's B. We'll keep same direction, opposite direction. How do you add A and B? We learned we use this two. This is A, that is B. We use A and B to construct a parallelogram. And the resultant will be A plus B. So they're pretty much same. Well, obviously, looks like not exactly because I did not use the ruler. We have to keep exactly same length for B and A, and you will end up the same thing. So this is a demonstration of how to add A and B, tail tip, and this is tail. Now, this comes to a point that if we want to do A minus B, actually A minus B is A plus a negative B. So in our case, that this is our A and that is our B. Therefore, a negative B is just same length but opposite direction. That is negative B. Negative B is only a name because if this is B, the negative B has the same magnitude but simply opposite direction. So if we want to add A and another vector named negative B, how do we do that? We just need to choose either one of the methods. So if we decide to do tail tip, then we move this negative B to here, see? Because this negative B, same length, this is a negative B, right? Now, A's tail tip, negative B's tail tip, and then this is the resultant. What is the resultant? The resultant is A plus negative B. That's A minus B. Isn't that interesting that your a minus b is this green one? It's longer than the a plus b. So for the vectors, a plus b is a resultant vector. Not necessarily will have larger magnitude than that a minus b's, because a minus b, in our case we constructed a plus a negative b, and end up this resultant is look like, and also obviously have a bigger magnitude than a plus b. So this is not number addition, that is vectors addition. It's different. Now we need to add vectors mathematically. In order to do that, I need to introduce a so-called unit vector ijk. Unit means that the magnitude equal to 1. So how do I say its magnitude? We just put two bars, equals to j equals to k's magnitude that equals 1. That's called unit vector. The magnitude is 1, but direction, i's direction represent the positive x direction. J's direction present as positive y. Obviously, k's direction is the positive z direction. So if I have a negative 5j, what does that mean? That means it is opposite direction of the positive y of 5 units. That's negative 5j. So with ijk, we can present our vector in a mathematical way. For example, look at this a. This vector a has an angle. We can either give a number or we can just name theta of a. So this is a vector in a variable, a magnitude and angle. This is look like a plane polar coordinate. So how do we describe this vector mathematically? Well, we learned that in the Cartesian coordinates, the y equals to magnitude a times sine of theta. The x, which is right here, equals to the magnitude of that distance and cosine theta. So this is how many units around x, how many units around y. Therefore, vector a can be expressed as x of I plus y of j. So if you know this point, P's coordinate, this is an OP vector or vector A. It is the x position times I plus y position times j give us an expression for this vector. So in our case, this is a cosine theta, theta A of I plus a sine theta of a of j. We use I and j to express our vector a. Now, look at our vector b. Remember, we have to follow the definition of the angle. All the angle has to start with the positive x-axis, turn counterclockwise. So therefore, this angle is theta of b. Right now, theta of b is more than 90 degrees. So if we want to express b, we say b's magnitude, cosine theta b of I, plus b's magnitude, sine theta b of j. Now take a look. If theta b is more than 90 degrees, that's the case, then cosine theta b is negative. So that's right, because the x component of this b vector, look at here. This is the x component of b vector, which is on the left side of the origin, opposite direction of positive x. So it's negative how many units right here. But the y is still along the positive side of the y-axis. That's why. Because sine theta b, if theta is more than 90 degrees, sine is still positive. If we look at another case, for example, if this is our positive x and that is our positive y, if we describe a vector, let's say, remember we have a vector like that, then the angle will be more than 180 degrees. Let's say this theta is 230 degrees, for example. And this is a vector C. So if we want to express C, that C is magnitude C of cosine 230 degrees of I. Obviously that cosine 230 is negative because it has a negative x. This is the negative x. This is how much of negative x for this vector. And plus a C of sine 230. This time sine 230 is negative j, because look at this, the y here is negative. So it automatically comes out I turn is negative, j turns negative, because this angle is 230 degrees. So as long as we follow the definition of 0 is positive x-axis, all the angle has to be measured counterclockwise, starting from positive x, then all the x component is the magnitude of vector times cosine of that angle. Y is magnitude sine of that angle. It will come out just fine.